Number 23, the power emitted by a spherical black body at temperature, absolute temperature TSP. The absolute temperature of the black body is halved and the radius is doubled, so that the power emitted becomes P dash. What's P dash all over P? So I think luminosity here is power, so I'm going to have to use this equation. I hope it's right. 4 pi r squared sigma t power 4. So let's let that be dash, luminosity dash. And this is all over L is equal to 4 pi r squared sigma t to the power of 4. So of course the 4 pi's cancel, the sigmas cancel. This is t dash here and this is r dash. So it says the absolute temperature of the block is halved and the radius is doubled. Okay, so we're going to get L dash is equal to R squared T to the power 4 all over L. So the radius is halved, so it's going to be R over 2. No, the temperature is halved. This is T over 2, power 4. And the radius is doubled. This is 2R squared. Okay, so then that's going to be equal to the r squareds cancel, t to the power of 4 is cancel. So it's going to be equal to L dash all over L is equal to it's going to be 16 all over 4. So it's going to be C, which is a quarter. So number 24, control rods are lowered into a thermal nuclear fission reactor. So this is a knowledge question again. And we use control rods to decrease the overall rate of fission occurring in the reactor, so the answer is A. Number 25, again this is a question I'm not really sure about. I think the answer is D. Wind turbine blades require constant wind supply. I can't see C really affecting the maximum power. The air is compressed by the wind turbine blades. A shadow effect I've never heard of before. The wind leaves the turbine with non-zero speed. Well, yes, but it always does that for any turbine, so I think the answer is D, but it's just best guess. I don't know whether that's correct or not. Okay, number 26. An object performs simple harmonic motion. When the displacement of the object is x naught over 2, the kinetic energy of the object is E. What's the total energy of the motion? So I think this is one of the most difficult questions in the paper, and this is my solution. I don't know if it's right, so anyway, here we go. So we know the total energy is equal to the kinetic energy plus the potential energy. So we're told in this question, when the displacement of the object is x naught over 2, the kinetic energy of the object is E. So let's look at the kinetic energy. Kinetic energy for simple harmonic motion. I'm just going to say it's a half k x naught squared minus x squared. So in this case, x naught over 2 is given, so it's going to equal to half k x naught squared minus x naught squared over 4. So that's equal to half k 3/4 x naught squared. So I'm going to write that as a half k x naught squared times 3/4. So that's the kinetic energy. Let's look at the potential energy now. So the potential energy is going to be half k x squared over 4. It's going to equal to half k x squared, say, times quarter. So we know that the kinetic energy is equal to E here. So we can say that half k x naught squared is equal to 4e all over 3. So we can put that into our potential energy formula. So we get 4e over 3 times a quarter. So these cancel there. So then we can say the total energy is E plus E over 3. So it should be 4E over 3. B. Like I said, I think this is a very difficult question. The probability of getting it right in 1.5 minutes is very low. There's a lot of calculation work, and I'm not even sure if this answer is correct, but I think it's B, 4E all over 3. Number 27, light of wavelength 400 nanometers is incident normally on the diffraction grating. Slit separation of the diffraction grating is 1 micrometer. What's the greatest number of maximum that can be observed? Okay, so we know the formula for this is sine theta is equal to n lambda all over d. So it's quite easy to put the numbers into this. So lambda is given as 400. This is 400 by 10 to minus 9. And slit separation is 1 by 10 to the minus 6 times n. So we put this into our calculator, we get sine theta is equal to n times 0.4. So the sine of theta means theta is equal to 23.6. So 90 divided by 23.6 is going to be less than 3. So the greatest number of maximum that can be observed is going to be 3, B. So number 28, our reflecting surface is covered with a thin film of refractive index n, the thickness T. The refractive index of the reflecting surface is greater than the refractive index of the thin film. So we're given this diagram. Light of wavelength lambda is incident normally from air onto the thin film. What's the minimum thickness of the film for which no light is reflected back into the air? So the formula for this one is going to be 2 nt is equal to m plus 0.5 because it's destructive interference. There's no light reflected back again. N, of course, is the refractive index. T is the thickness. M is just some constant from 0, 1, 2 up to whatever. And lambda is the wavelength. So the minimum thickness will mean M is equal to 0. So we have 2 nt is equal to lambda all over 2. So the minimum thickness is going to be equal to lambda all over 4n. So it should be A. Okay, number 29. One of my least favorite types of questions. It's the Doppler effect. A microphone M on a moving train detects the sound from a stationary speaker L placed on the track. The track is straight. L emits a sound at constant frequency. The frequency detected by M is continuously decreasing. So the which option is it? Well, if the frequency is continuously decreasing, I think from our experience of real life, we know immediately that it's moving away from L, because we all have heard the police car coming towards us where its frequency is increasing. It's like meemaw, 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 and then as it goes away, it's meemaw, 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 meemaw. So yeah, I think then it's going to be either A or B. So it says the frequency is continuously decreasing. So again, best guess here, I think it's moving away from L at a constant speed because it's continuously decreasing. So I think it's B, best guess, but again, I don't know really for sure. 29B. Okay, number 30, this one about the two spheres M and N. They're quite close to one another, and you have to find out what the variation of G is with X. So we know that G is going to decrease as you move away from the surfaces of each sphere. So there must be a point in between the two of them where the two gravitational forces balance. So that would mean it's either going to be A or C. Because M is the bigger mass, I think that the gravitational field strength will decrease more slowly from the surface. So I think the answer is A. Graph A. Number 31. Radius of a spherical planet is R. The surface of the planet, the gravitational potential is minus V. What's the gravitational potential R above the surface? Well, we know that minus G M all over R is a formula for potential. So if it's 2R above the surface, the gravitational potential must be halved. It's 2R. So answer is C, minus V over 2.